With accurate tracking solutions in place, creating compelling user-specific face rigs is currently a major challenge for the new interactive applications in online communication. In this paper, we propose a software pipeline for building fully rigged 3D avatars from handheld video recordings of the user. The pipeline we propose is split into 3 stages: static modeling, dynamic modeling, and animation. The user first records himself with a neutral expression by sweeping a handheld cell phone camera around the face, capturing images in burst mode. To acquire the back of the head, the assistance of a second person might be needed. We then ask the user to record a video in a frontal view while performing different expressions to capture user-specific dynamic face features. The uncalibrated images recorded by the user are processed using a state-of-the-art structure-for-motion software to obtain a dense point cloud. We register a morphable face model to the point cloud to compute a template mesh that roughly matches the geometry of the user's face. The registration accuracy is improved using non-rigid registration based on thin shell deformation. The next step in the pipeline is the reconstruction of a high-resolution albedo texture. We first combine all images using Poisson integration. Since the input images contain the specific lighting of the recording environment, we apply an optimization to factor out the illumination. Missing parts of the texture are filled in using an in-painting algorithm. Please see the paper for more details. Here are some examples of the output of the static modeling phase. The goal of the dynamic modeling phase is to complete the face rig by reconstructing user-specific blend shapes as well as dynamic normal and ambient occlusion maps. In this sequence, we show how the initial blend shape model obtained with deformation transfer is adapted to match the user's open mouth expression. We further improve the accuracy of the blend shapes using a 3D refinement step. We extract one depth map per frame using a photometric approach. Non-rigid registration is used to refine the blend shapes. This way, subtle details such as the bending of the cheeks are adapted to the actor. In order to capture small-scale details such as wrinkles, we automatically extract a set of dynamic detail maps from the recorded video frames. A corresponding ambient occlusion map is extracted for each frame. To augment the blend shape rig, we synthesize dynamic details on the fly by blending the reconstructed detail maps of the dynamic modeling stage using a local strain measure evaluated on the posed blend shape meshes. A radial basis function regressor is trained offline. At runtime, a shader implementation allows for real-time computation of the dynamic detail maps. We show a series of animations using the rigs created by our system. In our first example, a user drives his own character using the live markerless tracking software FaceShift on the laptop on the right. The tracking parameters are transferred over the network, and the computer on the left renders the expressive avatar at the same frame rate. Next, we show multiple examples of avatars being animated by the same actor or by different actors. Please notice how the expressions and wrinkles differ from one avatar to another.
So a few days ago, we spent all this time on coursework for AI, and it was really exciting. It was a very hard assignment, but in the end, it came out to be really good. And I lost some sleep, but I think that's all right. It was definitely worth it.
Je dois dire que je suis vraiment très content de pouvoir participer aux expériences. J'ai failli dire le nom. Bien qu'il fasse pas du tout beau aujourd'hui, il fait un temps plutôt sombre. On a réussi à trouver de la lumière ici. Bon, malheureusement, tout à l'heure, il va falloir que je retourne travailler. C'est bien triste. J'aurais préféré continuer à travailler avec mon collègue.
Thank you for your attention.